Hello and welcome everybody to the Chem Shack. This, as you can tell, this is where I do most of my personal chemistry. Just kind of cool, fun experiments and things. Go Tigers. So today, what we are going to be discussing is the concepts of chemical nomenclature. Alright. So, today, I'm going to teach you how to name a chemical. So whenever you're naming a chemical, the first most important thing that you want to do is determine if your chemical is ionic or molecular. Alright? So remember that if something is ionic, that means that you have a metal bonded to a non-metal. And then if you have something that's molecular, that means that you've got two non-metals bonded together. So those two things have entirely separate naming rules. And when you're practicing this on your own, you can look at these sets of rules here that I've laid out for you. I'm not really going to go through them now. It's just for you to work on it if I'm not there helping you. So molecular things have their own set of naming rules. And whenever you get this question on the quiz, you're going to have the question divided into one whole quiz question that's just a molecular naming one, and you'll have one that's just an ionic naming one. So if we're looking at something that's molecular, like this one, for example, we have SO2, that's two non-metals. So if we're going to name that, really the only thing that you need to know is first what the Greek numerical prefixes are. So if you don't know those, you'd want to know that 1, make that a better 1. 1 stands for mono. 2 is di. 3 is tri. 4 is tetra. 5 is penta. Penta. 6 is hexa. 7 is either septa or hepta. You'll see it referred to both ways. 8 is octa. 9 is nona. And lastly, 10 is deca. So just be aware of all those. Whenever you have to do a molecular name, you could be asked to put anything from 1 to 10. So just make sure you know them. Alright, so if we're doing a basic molecular name like SO2, really the only thing you have to remember aside from prefixes is that the first element does not take the prefix mono. So we're not going to call this monosulfur dioxide. It's just going to be called sulfur. And then because we have two oxygens, we'll call it dioxide. Okay, so basically if you didn't understand what I did just there, I didn't put any prefix with sulfur because we only have one sulfur. And you never put mono with the first thing. If you have multiple of the first thing, you can use any other prefix that is necessary, but if there's only one, just don't use mono. And then I put a di before oxide because of the fact that we had two oxygens, so I needed to say di for 2. Don't get hung up on the way that things are spelled. It's really not important. You know, you're going to be taking a multiple choice test. So he's not going to waste two very, very similar answers trying to get you to screw up the precise spelling. You know, if you know di means 2, you should be pretty much okay. Okay, and then on to a slightly more complicated example there. So, moving on along. Okay, so we got N2O3 here. So basically same idea. It's still a molecular compound. Nothing really too fancy here. We've got 2 nitrogens, so we're going to call that dinitrogen. Then we've got 3 oxygens, so we'll call it trioxide. So dinitrogen trioxide. Pretty simple. Okay. Then, maybe a little bit more complicated, you have P4O8. So 4, if you recall, was tetra. So that means that we're going to have tetraphosphorus, because that's a phosphorus, if you didn't know. And then we have 8 oxygens, so we'll call that octaoxide. So P4O8 would be called tetraphosphorus octaoxide. And really that's as complicated as a molecular compound name will ever really be. It's not that sophisticated. Okay, so if we move on along, next I'm going to have some ionic names to do. As soon as I dispose of these notes here, we don't really need those anymore. Okay. So, hopefully you've already recognized that these are ionic because these have metals in them. Sodium is a metal, calcium is a metal, iron is a metal, obviously. So the way that you name an ionic compound is much more complicated. It really all has to do with the whole charge situation that you have going on. You want the charges of the thing that you're naming to balance out the zero. That's like the whole name of the game with ionic naming. So hopefully, if you were at the first session, you remember that I talked about how each of these columns has a charge associated with it. So the first column you would want to know has a +1 charge. The second column has a +2 charge. We skip over this whole blank here. All of these, I don't really care about them. Those are called transition metals. As far as charges at the top of their column, it's not really relevant because it can be all kinds of things. This column is +3. The column with carbon, we're going to skip that for now. This column is -3. Then -2. -1, and then lastly, the column with all the noble gases has a charge of 0. Okay? So, if we want to name NaNO3, we need to know first those charges, and then the other very, very important thing that you have to be aware of are these things down here, all of these. So these are called polyatomic ions. If you have trouble reading them on this video, they're on the second worksheet that I have on Moodle. These are things that you really want to be very familiar with. As you can see, we have one right here, NO3, which is NO3 nitrate, as you can see here. Nitrate, NO3. So, basically the issue with these things is that polyatomic ions, such as NO3, they never split up. They always stay together, and they make naming, particularly naming ionic things, a lot more complicated. So if you don't have this list of polyatomics memorized, then you won't know how to name these things. And I'll show you why. So we have a sodium. Okay, and so sodium carries a +1 charge, as you can see here. Sodium +1. Alright, so I like to just write out what I got. We know that we have a sodium that's +1. Then, you also know that you have an NO3. And because you memorized your list of polyatomic charges, polyatomic ions, you know that the charge on NO3 is -1. Okay? So That's what we got. We got an Na plus 1 and an NO3 minus 1. So right away, those two charges cancel each other out. So there's no balancing that needs to be done. Already, that's even. So whenever that occurs, whenever two things' charges are balanced, then you can just write it exactly as you see it. Alright, so like I said, we've got these two compounds here that have canceled each other out. We've got sodium plus 1 and nitrate, NO3, minus 1. So whenever you get two charges that balance each other completely like that, all you have to do is just write it exactly like you see it. I see a sodium and I see a nitrate. So I'm going to call this sodium nitrate. As simple as that. Okay? So then, if I move on to something perhaps a little bit harder, I've got CaOH2, where there's two of these OHs. So obviously the first thing that you'd want to be aware of is that anytime you see something that's got kind of multiple atoms in it, like that OH or the NO3, that usually means that you're working with some kind of polyatomic ion. So in this case, it's OH minus, which is also called hydroxide. So we have a calcium and we have a hydroxide. So calcium, right here, Ca, is a +2 charge. So I'll write that out. We've got a Ca, which is +2. And then you have two OHs, each of which has a -1 charge. But the thing to realize is that because we have two of these OHs, that means that the whole negative charge is -2. So just like the example above, we have a -2 and we have a +2. They cancel each other perfectly. So whenever that happens, you just write it exactly like you see it. Calcium hydroxide. Calcium hydroxide. And so something that's really important to note with ionic names, even though I've got two OHs here, because this is an ionic compound, I'm not going to call this calcium dihydroxide. Ionic names never use prefixes. That's only for molecular compounds. So no prefixes here. A lot of times whenever you're taking the quiz, there will be questions that it's clearly an ionic formula, but they'll have prefixes in the answer choices. That's a really easy way to rule out answers because ionic names will never use those. Okay, so then we've got FeS2, or sorry, FeS. So this is another ionic name. So we have an Fe and we have a sulfur. So the problem here is that iron, Fe, that's a transition metal, something in the middle, something that can have a variable charge. I didn't give you a charge for the top of this column because it can be anything. So that means that we don't know the charge of this iron. In other examples, we could just look at the table and figure out what the charge of our metal was. But in this case, we don't know. So we have to figure it out. So if we move on, the other thing that we know we have is a sulfur. So sulfur, as we know, sulfur carries a -2 charge. Okay? So that much we know. Now earlier I told you that the whole point of naming an ionic compound is trying to make sure that the charges come out to 0. So we only have one iron and we only have one sulfur. We don't know the charge of this iron, but we know that the whole negative charge in this entire compound that comes from this sulfur is -2. So if we know that this iron has to cancel this sulfur, then the charge of this iron has to be +2. Because that's the only way that this can cancel this, just like they did previously. So whenever this kind of situation happens where you have to figure out a charge, that usually means that you're going to need to include a Roman numeral in the name. So we have iron, but specifically this iron, as we figured out, is +2 iron. So that means that we're going to include a Roman numeral 2 after it to denote that that's the charge of that iron. And then we know that we have a sulfur, so it becomes sulfide. Some crazy penmanship there. Alright, so iron 2 sulfide. So one quick note about Roman numerals. You will only ever use Roman numerals with transition metals. Things that do not have an established charge. Anything else, like if you can just look up at the top of the column and see that it's got a certain charge, you're not going to use a Roman numeral for it. But if it's something that doesn't have a charge, Roman numerals are okay. You should use them. Okay, so FeS, iron 2 sulfide. So next, I've got a couple more complicated examples of some ionic names. So over here I have, we've got CuCl2. So in this example, we have a copper, Cu, and we have a Cl2. So this copper, Cu, we don't know the charge of that. Cu is a transition metal. We have no idea what's going on with that one. But Cl, we know that chlorine has a -1 charge for each chlorine, and we have 2 chlorines here. So that means that our total negative charge is -2. We only have 1 copper, so clearly this 1 copper has to cancel out the -2 from these 2 chlorines. So that means that the only charge this could possibly have must be +2. So that means that the name for this one would be copper, Roman numeral 2, chloride. And again, remember, ionic compounds don't use prefixes, so I'm not going to call that dichloride or something. Okay, and then probably one of the hardest ones on the worksheet here, Fe2S3. So you've got iron and you've got sulfur. So once again, iron, that's a transition metal, you don't know the charge. But sulfur, we recall that sulfur, each sulfur carries a -2 charge. And we have 3 sulfurs. So that means altogether there's a -6 charge there. -2 times 3 is -6. So then we have 2 irons here. And we know that those 2 irons have to cancel out a -6. So if each one of these 2 irons was +3, then that would give us +6. Because +3 times 2 equals +6. So that means that we're going to call this iron Roman numeral 3, because each of these 2 irons was a +3. So iron Roman numeral 3 sulfide. Okay? So pretty straightforward. And then last but not least, I'm going to talk about examples where you could have to deal with like going backwards through this whole process. So if you have, for example, say, I'm just trying to destroy my work here, you know, and it's just not working. You try to make things exciting, but what can you do? Okay, kids, looks like we're gonna have to go to the floor for this one. Table's kind of getting out of hand. So, oh Jesus Christ. Okay. Okay, everybody. Now that all this chaos is out of the way, all right. So, this is sort of special here, what we're doing, because this is the whole process of kind of doing everything I just showed you how to do, but backwards. This is especially important because this will allow you to go from you know, like a written out name to a formula. What's so important about that is that a lot of times you'll see sort of a higher end math problem, and they'll tell you, you know, you have 6.38 grams of lead 2 oxide, and then you do all these crazy reactions with it, how many moles are left at the end or something like that. Even if you know how to do the math, if you can't figure out how to turn this into a formula, then, you know, you're screwed. So it's really important that you be able to go from this into a formula. And this is the last thing we'll talk about today. All right, so just like before, it's very important that you first assess whether or not you have a molecular or if you have an ionic name. So hydrogen and bromine, those are two nonmetals. Hydrogen and bromine, two nonmetals. So that means that we're going to use molecular naming rules to take this backwards a step. So because molecular naming rules use prefixes, that makes this extremely easy. If there was any prefix here, like if there was any more than one hydrogen, they would have to say so, because that's how those prefixes work. If there's only one of the first element, you know, you don't put mono. If there's more than one of the first element, you put whatever prefix goes with it. So because there's no prefix here, that means there must only be one H. And then, likewise, the same with this bromine. If they had put some other prefix, I would have known that there were however many bromines. But because they didn't put a prefix, that means that there must only be just one bromine. So that means that we are dealing with HBr, or HBr, if that's easier to see. Okay. And then another one that I got a lot of questions about, carbon monoxide. This is basically the exact same situation. This is the last one for molecular names that I'll do just because they're so easy. So carbon, if they had put a prefix here, then I would have known there were more than one carbon, but there's no prefix, so there must only be one carbon. So I know that the formula starts off like that with a C. Then they say monooxide. They were helpful there, and they told us that there was only one oxygen. So we know that the formula is CO. So carbon monoxide is just CO. That's it. Okay. So then on to ionic things, a little bit more complicated. So we have a lead. So that's Pb. Lead is Pb. And then they tell us that that lead is positive 2. That's what the Roman numeral is for. So we've got a lead plus 2. Then they tell you that there's an oxygen there. Okay? And we know, because of the periodic table, that oxygen carries a -2 charge. So this is what we have. And conveniently, they balance each other out perfectly. So that means that this is the name. It's just, or this is the formula. It's just PbO, because they balance each other like they are. And then, lastly, an example of what happens when they don't balance each other out. So cobalt, that's CO. Or here, write that bigger. So we've got CO. We know that it's plus 2. And then we have a nitrogen, nitride. Okay? So nitrogen is a -3. Okay? So because this is ionic, we know that we need to make these charges balance each other to get the final formula here. However, these don't really balance each other in a clear ratio, so you have to figure out a way to conveniently put them together where their charges give you 0. So the easiest way to do this is something called swip swap soda pop. That's my term. We're going to use those charges and turn them into the subscripts. Okay, so this -3 became the subscript for the cobalt, and this +2 became the subscript for the nitrogen. And if you break it apart, so if we have 3 + 2 cobalts, 3 times 2 gives you 6, and then if we have 2 -3s, that gives you -6, and therefore they cancel each other out. Okay, one last note. So about these endings here, one question that I get a lot is, how did I know that this was just an N? So if they wanted you to put nitrate, or if they wanted you to put nitrite or something like that, they would have specifically given you NO3 or NO2 or something like that. If it just ends in IDE, like all these other things do, then that just means they're talking about the basic singular element, oxygen, nitrogen, whatever it is. But if they specifically want you to say nitrate, nitrite, phosphate, sulfite, something like that, they're going to give you that exact combination of elements. All right, everybody. I hope you've enjoyed your time in the Chem Shack. Say goodbye, everyone. Farewell, and I'll see you next time.
I hope you've enjoyed learning how to name chemicals with me, everyone. This is Ryan Sullivan, signing off. Keep it crunk, everybody.